So for this one, we're just going to use, it says you do not need to use the definition of derivative, so we're going to use the derivative rules, differentiation rules. Okay, so dy dx is going to be equal to, I'm just going to take the derivative, so it's going to be the 2 is a constant multiple, so that's going to stay put, 2 times, the derivative of x to the 5th is 5x to the 4th, minus the 9 is a constant multiplied by a function of x, so it stays put. Derivative of x squared is 2 times x. An 11 is a constant multiplied by a function of x, so it stays put. The derivative of x is 1. So if you wanted to simplify that, that's 10x to the 4th minus 18x plus 11. Okay, the next one, x to the pi times e to the x. And so I want to notice here that on this one we have an x here in the denominator, and this one we have an x in the exponent. So when you have an x as the base of a power, we're going to use the power rule. When you have an x up in the exponent, you're going to use your exponential rules. So I just wanted to point that out. The other thing I wanted to point out here is that you have two functions multiplied together. So it's a product of two functions, which means we're going to use the product rule. So f prime of x is going to be equal to, I'm going to take the derivative of the first function. Now that's just a power of x. So it'll be pi x to the pi minus 1. And then e to the x is going to stay the same. Plus, now I'm going to leave x to the pi the same and take the derivative of e to the x. The derivative of e to the x is just e to the x. And so I'm done with that. For the next one, I'm going to use the quotient rule. And so if we remember, this square root of t can be also written as t to the 1/2. So I'm just going to write it as t to the 1/2. I think it'll make it a little easier. And if I want to find dg dt, I'm going to use the quotient rule. I think it helps if you write out your parentheses ahead of time, so you can kind of make sure you put everything where it needs to go. Okay, so the quotient rule, we're going to do low d high, so t to the 5/3 times the derivative of the top. Well, by power rule, it's going to be 1/2 times 2 is just 1t to the 1/2 minus 1 is negative 1/2. Okay, and then I'm going to do minus, so that was the bottom times the derivative of the top, minus the top times the derivative of the bottom. So 2t to the 1/2 minus 7, and the derivative of the bottom is going to be 5/3 t to the 5/3 minus 1. So 5/3 minus 3/3 is going to be 2/3. And then over t to the 5/3 squared. So that's my derivative. And if I would recommend not simplifying it, just leave it like that. You don't want to simplify it and make an error. Okay, for the next one, in the space provided, write the letters of the expressions which are valid for the graph. Okay, so each graph will have at least one matching and some could have multiple. Okay, so here I have a jump discontinuity at A. So it says, does the limit of A exist? So for this graph here, I'm going to go through each of these. The limit does not exist. Does f of A exist? Yes, it does. So B is 1 here. Because f of A exists, there's a filled in dot there. Is it true that the limit as x approaches A exists, but the limit is not equal to the point? So that would be like for a removable discontinuity. That is not the case here. What about D? The left and right hand limits do not equal one another. That's true. This would be the definition of continuity. So this is not true for this one. The limit as x approaches infinity of f of x exists. So if I look at this function, as x gets bigger and bigger, it looks like my function is going off to infinity. So that limit, we would say, does not exist. The limit as x approaches negative infinity exists. So if I see that, it looks like it's going to negative infinity, so we would say that limit does not exist. The limit as x approaches A from the left of f of x equals infinity. So that is not true because the left-hand limit is approaching some finite y value. And the limit as x approaches A of f of x equals infinity. So that would be if the left and right-hand limits are both going up. to infinity, so that is not the case here. So it's just b and d on this one. Okay, so for the next one, actually I think I'm going to go, okay. All right, for the next one, okay, so let's see which ones have a limit that exists. So what does the left and right hand limits exist? So here, A is here. Does this have a limit that exists? No. Does this one have a limit that exists? Yes. And where is A on this one? I don't even see a point A on this one, so the ones that involve A don't even make sense here, okay? For the next one, so we've done all the A's. Okay, for the next one, f of A exists. So we need a dot, filled in dot on the point A for this one to be true. So the first one is no. The second one is no. The third one is, oh, the first one is yes, sorry. So there is a filled in dot there. So B goes there. Yes, it exists here. And f of A exists. Okay, that one doesn't apply. Okay, so we've done that one. The next one, the two-sided limit exists but is not equal to the point. So that would be like a removable discontinuity where the point exists. So I think none of those are going to be the case. So C is none of them. D, the left and right hand limits are not equal to one another. So that would be here, the first one. The second one, the left and right hand limits are equal. The third one, the left and right hand limits are not equal, so D goes there. On the next one, the left and right hand limits are the same, and the last one, A, there's no A there, so it doesn't make sense. Okay, so the next one, the limit is, so this is continuity. So the only one that's continuous is this one here, so that's E. Okay, and then for this one, the limit as x approaches infinity of f of x exists. So for this one's going off to infinity, that one's going to negative infinity, that one looks like it's going to negative infinity, negative infinity. So none of these are the case, so f is on none of them. What about G? The limit as x approaches negative infinity of f of x exists. So if I look, that one's going to negative infinity, that one's going to infinity, negative infinity, negative infinity. This one is going to a finite number. So the only one that works for G is this one. Okay, and then the limit as x approaches A from the left is infinity. So the limit as x approaches A from the left is infinity. That's the only one that works is this one, H. And the limit as x approaches A of f of x equals infinity, that's for none of them have that. Okay, so I think we're done.